Well, hello there. So in this video, we're going to be taking a look at oligopoly, and we're going to actually do three practice problems related to oligopolies and game theory. Again, my apologies, I'm recording in this utility closet because we've returned to in-person learning and I don't have any safe place where I can actually breathe the air. So here we are in a closet learning game theory. So you've got these two players, Glossinger, that's me, and Sywell, that's my mortal enemy, and they can go to either the nightclub or the movies. And this question is going to give us what's the dominant strategy for me? If Sywell goes to the club, what should I do? And what will the two people do? Where will they end up, right, is what this one is saying. So this one is saying, what's the Nash? And where will they end up if they don't collude, right, which we aren't going to. So the way we're going to do this is just solve the problem first, and we're going to do that with all three of these, and then we'll kind of answer the questions. I find it easier to do that. So let's play as me first, since it's me, right, Glossinger, and I have two choices. I can go to the club or the movies, and if I play, I'll get either 2 or 5 utils if Sywell goes to the club. Well, if Sywell goes to the club, I would prefer 5 utils to 2, so we'll circle that. And then if Sywell decides to go to the movies, I look here and I say I could get 4 or I could get 3. I'm going to go with 4. And so clearly I don't have a dominant strategy, right? I might go to the movies or I might go to the nightclub. It kind of depends. So none, we would say. And then here we'll kind of look at and see what happens if we play as Sywell for a moment. So assuming that you're Sywell, you would say, well, what if Glossinger decides to go to the nightclub, right? If Glossinger goes to the nightclub, Sywell can get 6 by going to the movies or 4 by going to the club. Now, when we're playing as the top player, we look across, top, look across. If we're playing as the left player, we look up and down. Left player up and down, top, we look across. And so we're going to look at 4 or 6. And so if you're Sywell, you prefer 6. Now, if Sywell is thinking Mr. Glossinger is going to go to the movies, then Sywell can get 8 by going to the club or 1 by going to the movies. And so he would choose that nightclub and get 8. So we actually have 2 different Nash equilibria, and we'll write those down in a second, but this is actually a common occurrence. You can have 0 Nash, 1 Nash, 2 Nash, or all 4 of them could be Nash equilibria. That would be very unusual. But with a 2-player, 2-strategy game, you can't have 3. It's just a mathematical impossibility. Now, if Sywell goes to the club, right, Sywell chooses club, then what will Glossinger do? Well, Glossinger will go to the movies. And we have the 2 Nashes, so we'd say Gloss to the movies, and Sywell to the club, it'd be nice if I could spell, right? Or, and the other one is the other alternative, which is just as likely, would be Glossinger to the club and Sywell to the movies. And so this is what we call a game of avoidance, where we don't want to both end up in the same spot. And that's relatively common actually in the financial world, right? You want to kind of compete for different market segments. And a lot of times oligopolies will do that. They'll try to avoid kind of getting in each other's way a little bit. So let's take a look at this next one here. This next one's firm A, firm B. They choose advertise or not. And these are like how much they earn. So kind of thinking about how much money do they earn in determining a dominant strategy, blah, 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 blah. Let's go ahead and solve the problem first. If we play as firm B first, if firm A chooses to advertise, then we can either get 100 by advertising or, what does that say, 75. My eyes are getting old. We could get 100, so we prefer 100. If firm A decides to not advertise, well, if I'm firm B, I can advertise and get 90, or not advertise and get 60. I'll choose to advertise. So pretty clearly firm B has a dominant strategy to advertise. They'll always do that. What about firm A? What are they going to do? Well, they know that firm B will advertise because they have perfect information. And so they can choose either advertise and get 85 or not advertise and get 80. And in that case, they'll choose 85. Now, firm A, we're going to go ahead and solve this one. What if firm B didn't do the optimal and firm B not advertised? Firm A could get 60 or firm A could get 70. Which are they going to prefer? Well, they prefer 70 because we're looking across. 70 is bigger than this 60. And so that's what they'll do. So firm A does not have a dominant strategy. Now it says in determining a dominant strategy for firm A, what will A earn if B advertises? Well, if B advertises, then firm A will choose to also advertise. And so they make 85. If firm B does not advertise, which we know they won't, they have a dominant strategy to advertise, but whatever, what will firm A earn if they make their appropriate decision? So if firm B does not advertise, firm A will choose to not advertise. And how much do they earn? They earn 70. And so we're looking for that number. What's the dominant strategy for firm B? Well, we established that earlier. It is to advertise. And again, so these are kind of thinking about their payoff matrices. What are they going to do? All right. Last one is a slightly longer problem. This is modeled on a AP problem. And I actually realized I made a mistake afterwards. So where it says companion, we're going to scratch that out and write Picklemans every single time. And that's my own fault. The companion closed. So 2 sandwich shops where we live. So does each shop have a dominant strategy set high, low, or whatever? Let's go ahead and solve it first. So if your Picklemans and Potbelly goes high, you can get 105 or 120. And you're going to choose the 120. My pen is pooping out. I got to get a new one. Potbelly, if Potbelly goes low, right, then your Picklemans, you can get either 40 or 75. You're going to choose 75. So pretty clearly, Picklemans has a dominant strategy to go low, because they're always going to choose that low option. Now, Potbelly, on the other hand, right, if Potbelly thinks Picklemans will go high, then they can either get 110 or 130. Which one? Well, they're going to prefer 130. And if Potbelly thinks, all right, you know, if Picklemans is going to do their low price, then we could get the 80 instead of the 70. So take a look here. So we do have a Nash. It's at the low-high outcome. So Potbelly does not have a dominant strategy. And that's because they're not always choosing high or always choosing low. If the 2 shops do not cooperate, what are they going to be the profit? This is another way of saying what's their Nash. Right? So if you see don't cooperate, that's just where they end up. So low is where Picklemans goes low and they get 120. Boy, if my pen makes it through this, we'll be good. And Potbelly gets 80. Oh no, my pen, oh no. All right, now it says the town government is concerned that food prices are too high. It decides to give a daily subsidy to 20 to any shop that sets a low price for its food items. So I'm gonna zoom out just a little bit here. And what we need to do is redraw the payoff matrix under the subsidy. So, oh boy. All right, I'm gonna pause and then I'll be right back. Okay, new pens. Whew. Had to run down to the office and put the mask on and all the hazmat stuff and whatever. Okay, so it's saying that in the intervening time, did you finish this problem? Okay, you were supposed to do that. All right, no, I'm just kidding with you. So we want to redraw the payoff matrix, and it says here we've got Potbelly, here we've got Picklemans, high, low, high, low. Okay, now the trick to these, and they are kind of tricky, is you add 20, but only to the ones where the shop price is low. So that's kind of tricky. So this first one, right, where they both go high, high, their numbers don't change. So we're just going to take 105 and 110 and rewrite them. 110. And then for these 2 corner ones where there's one party going low and one going high, one of them's going to change and one's not. So the party that's going low, 120 here, Picklemans, is going to get to be 140, but the 80 is going to stay the same. Now for this one, the one that's going high is the 40, that's coming from Picklemans on the left, so that one's going to stay the same, but the 130 is going to become 150. Now the bottom right corner, that one's easy, we add 20 to both. Okay, now we resolve this problem. So we'll kind of zoom in just a little bit here now that we've done that. Kind of move that up a little bit. All right, we've got to move it out of the way. I'm a hot mess today, I tell you what. Today is our second day back is when I'm actually recording this, and I'm having a little bit of a rough day. So let's see here. Picklemans, if Potbelly were to go high, Picklemans will choose to go low and get 140. And if Potbelly thinks, if Potbelly is going to go low, then Picklemans can go 40 if they go high, or 95 if they go low, so they'll also go low. So we observe that, right, that Picklemans stays low, that no matter what, Picklemans is going to price low. And then, now let's kind of solve it from the other way. If Picklemans does go low, Potbelly can get 80 or 90, and Potbelly would prefer 90, so they're going to go low as well. If Picklemans were to go high, which we know they won't, but if they were, Potbelly could go high and get 110, or low and get 150, and we know they'd go low and get 150. So now Potbelly has actually a dominant strategy to go low because they're in the same column. So it says, would Potbelly choose to set a high or a low? Explain using values in the matrix. And so for this one, we would say for C1, we would say low because, and then we just need to make the comparison here. We'd say 90 is bigger than 80, right? We know that they're going to be in this row because Pickleman's is always going to go low. And so they're going to choose between going low and getting 90 or high and getting 80, and they're going to go low and get 90. So that's our answer, just low because 90 is bigger than 80. Then it says, would profits for Pickleman's increase, decrease, or stay the same? Explain with a comparison to the values in B1, where we said they earned 120. Remember, they were here earning 120. So now let's see how much does Pickleman's earn. Well, now the Nash equilibrium has shifted, right? It used to be here in this box, and Pickleman's used to earn 120. But now Pickleman's is now going to earn 95. That's kind of strange, right? It's like Pickleman's didn't do anything. They were already pricing low, but as a result of this subsidy, the Nash equilibrium shifted, and so now they're going to only earn 95. So we would say the C2, they would decrease because 95 is less than 120. And that's all we have to do is basically say now they're earning 95 and they used to earn 120. And students sometimes think like, well, why would they earn 140? Well, because that's not the Nash. If they were here, right, what's Potbelly going to do? If Pickleman says, oh, we're going to go low and hopefully Potbelly keeps going high, well, Potbelly's not going to go high anymore. Potbelly's going to go low. And when they do, Pickleman's goes from 140 to 95. So Pickleman's will never earn this 140. It's kind of a red herring. They wish they could, but they're not going to because of this. So it's a little strange of an outcome. Anyways, we've got these 3 practice problems. The very next practice problem is actually an AP exam problem. So hopefully you do really well on that one. I'll see you next time.